Welcome to this next classroom session that goes alongside the IHI Open School course. I hope you're enjoying the course. Some people obviously may not have had much time over the last few months because of COVID-19, but I hope maybe now things are starting to open up in your schedule and you're able to find just an hour in a month to start doing a module. Those modules are really well put together. They're easy to follow. You don't have to learn a huge amount in one go, and they only take about an hour and 15 minutes each. So it really is worth starting to get into the swing of things if you haven't already yet. And these classroom sessions, these are optional. They run alongside the modules in the timetable, but they augment your learning because learning is a good thing to do as a community. And not just on your own at distance as well. It's really good to come together as well. So that's what the purpose of this is today. So we are going to learn about, cover about one of my favorite things really in quality improvement, and that's data. I'm just going to share the screen. So learning how to look at your data and represent it in an easy way to create a story that you can then allow other people to come on the same improvement journey with you is really important. There's probably two types of people. There's people who you can burn the platform by just creating a really emotive story and something that's fairly subjective but really pulls at heartstrings or really just rings true with them, and people who sort of rely on a lot of visual clues, stuff like that. But there are also people who really need data and objective evidence to come on board with you. And if you don't provide that, you will lose a huge chunk of people who you're trying to persuade and show what your improvement is all about. So then you need to use data. And the problem with data is that if you just show a bunch of numbers, it's very difficult at a glance to tell the story succinctly. It's also difficult for the person who you're telling it to interpret. So that's where run charts, control charts, Pareto charts, histograms, scatter plots, they all come in useful. So in this session, there's going to be a bit of a lecture to begin with, then a video to watch, and then an exercise at the end. We're going to cover run charts, cover the difference between common and special cause variation, cover quickly shoe heart charts or control charts, which are slightly different, how to apply the rules to identify whether you've got non-random patterns in your run chart, and then covering some of the other charts that I just mentioned. Okay, so here are the elements of run chart. Run chart is really simple, and it was actually designed to be used with paper and pencil on a factory floor. So you'd have along the x-axis, you have time or even individuals. So each point might be an individual widget coming off the factory line. And on the y-axis would be the thing that you're measuring, the thing that you're most interested in. Commonly in healthcare, this might be, for example, each one would be an individual patient from a ward, and the y-axis might be length of stay on discharge. That's something that happens to everybody when they go home. You know, they've stayed for a period of time, so you're going to get a good run chart. Something that's not so good on a run chart is things that don't commonly happen. For example, MRSA infections, which most of the time people don't have. And then only once in a blue moon, you might get a blip. Well, that's a fairly blank chart that won't really tell much of a story. So run charts are good for things that happen commonly to everybody, or something you can measure in every individual or every day or every week. And you just draw a line between each point as you go along. And then once you're interested in a particular section of time, you can then calculate the median across that, and you draw that as the median here. You could also draw yourself a goal line, which is where you want to get to. And this is particularly if you are running an improvement project. So now you are able to convey quite quickly with your improvement project what's happening along time, where we are currently in terms of the median, and where we want to get to. These other things like adding annotations. So that's really, really important. There's a gap here, and the annotation you might put in is that we changed computer systems and we didn't have any data collection at that point. There is perhaps a trend going on here. And if there was something significant in your improvement project that you did around about this time, then you would put a little annotation there saying what you did. And that instantly then conveys cause and effect, because you can see a change in the run chart after a certain time point. So how many runs on this chart? Well, a run is consecutive points above or below the median. Any points that are exactly on the median, you pretend like they weren't there at all. So if a point starts here, goes up to the median and comes back down, then the 2 points underneath are a run because you completely ignore the one on the median. So even 1 point is called a run. So you'd have 1 point here, 1 run, 2 runs, 3 runs, 4 runs, 5 runs, all the way under here. Now, if this is the break here, you might say, well, this is a 6th run. But because you might not know whether that's gone up there or down there. But in this example, they say it's part of the same run. So variation on a run chart is either because there is natural variation in your system, or because something is happening in the system or to the system that is causing the variation. So natural variation within your system is called common cause variation. It's the margin of error that your system has inherent to it. And without changing the system, you are going to continue to get that random variation. In special cause variation, there are patterns. There are things that are making it happen. So it's not inherent to the system itself or the system around it. It's something that's being done to it, either unexpectedly or intentionally. With common cause variation, you'll see that it continues to go up and down around the baseline median, and it won't change. So although one day it might be high, and then the next day it might be low, and you might be thinking, and then the next day after that is low again, you're thinking, is there starting to be a trend? If you've not changed your system and nothing's changed to it, then you can expect it to then rise back up and keep hovering around the baseline. So that's what we call a stable process. But those where there's an unstable process going on, things are not quite tied to the median baseline because something is happening. So in order to spot a special cause variation on the run charts, there are 4 rules, easy rules that you can apply just by eyeballing the chart. And that's why this whole tool was designed in the first place, because on the factory floor, you don't have computers, you don't have calculators necessarily, you're standing around a board, and you want to be able to instantly interpret this run chart. So rule 1 is that there are 6 or more consecutive points above or below the median, so they can just go up and down, but they need to stay above that median. Rule 2 is that there is a trend. So there's 5 or more consecutive points that are going in either up or down fashion. And for this rule, you ignore where the median is, because they can start below the median and go above, or they can start above the median and go down. It needs to be 5 consecutive points heading in the same direction. Rule 3 is that there's too many or too few runs. So on this chart, example chart they show, there are only 2 runs. There's one above the median, and then there's one below the median. So there's only 2 runs out of all these points. And that suggests that things are not random. It's a bit like flipping a coin, which is one of the examples in the module, or something being good or bad, I think is the example. But if you flip a coin, if you get heads, tails, heads, tails, heads, tails for the 20 flips, then that's not random, because you know from experience that the coin is going to sometimes land tails twice, or even 3 times, or even 4 times. The probability of it landing in a nice exact pattern is actually very, very small indeed. And the same goes for if it does tails for the first 10 and then heads for the first 10. That's just not the probability of that happening is very, very low indeed. Rule 4 is an astronomical data point. That means that something happened at around that point in time that caused everything to go way off. So if this was length of stay and then it suddenly went straight up, then maybe it was because, I don't know, something simple as we had a long weekend. Is there non-random variation in this one here? Well, it's hard to tell really. There's a baseline here. How many runs are there? There's 1. This one doesn't count. 2, 3, 4, 5, 6. Probably enough runs on the chart. Is there a 6 or more above or below the median? No. Is there 5 or more in a trend? 1, 2, 3, 4, 5. Yes. So there is possibly non-random variation because there's a downward trend here. Is there an astronomical point? Yes. There's one here which is above our goal line. So perhaps round about here they haven't annotated it. Perhaps they did something here, an improvement project, which lasted only for 1 month, and that caused us to reach the goal. But then sustainability wasn't built into the project and everything fell back down to the baseline quite quickly. So other helpful tools that we mentioned are a Shewhart chart. This is slightly different because it's got upper and lower control limits. And these are typically 3 standard deviations above and below the median, or the mean even. Shewhart charts are probably designed to monitor a process for quality control. So if you have a factory line and you want everything to perform, everything that you produce to be the same length, and you measure the lengths of what you actually produce, and there is some variation, you want to continue to measure that process to make sure that it's within an acceptable error. And if something goes above or below those upper control limits, an alarm would go off. Either, you know, just the manager would notice something up on that chart and then go and try and investigate it on the factory line to see if something happened. Maybe one of the saws needs replacing, for example. So that's how to monitor quality control. And that's where Shewhart charts were born. So if we've got a stable process within healthcare that we want to continue to monitor, for example, ED wait times, then that's something that would be useful to have a Shewhart chart where you have the upper and lower control limits. And also, by plotting this, it also tells you that if you have a system with these upper and lower control limits and you get something that performs within that region, then you know that nothing is ever going to change unless you change the system. So if your ED 4-hour wait median is 3.5 hours, or sorry, 5.5 hours, and your upper control limit is 8 hours, then you know that your system is going to continue to produce people who breach the time unless you actually change the system. There's no point looking for special reasons why that person was 8 hours one day and then the next person was 8 hours another day. the system is designed to produce to that degree of performance. So a histogram is a way of finding out where the majority of stuff lies. So if you can break things down into buckets, like for example age range, and you plot the number of things within each bucket, then you'll start to understand who contribute to who are the majority of the population coming through there. So you would maybe want to know your age range for the people who are presenting to ED, because that might help you focus an improvement project on the majority of people coming in. A Pareto chart is probably a bit more useful than a histogram, because it also then starts to show you visually what are the most common things, and it can help you split your cohort into the few categories which contribute to the majority of the problem. So it's usually the 80-20 rule. So about 80% of the stuff in the categories will contribute to the majority of, 20% will contribute to most of the problem. So for a scatter plot, the scatter plot is a way to show if there's any relationship between two data sets. So here's a Shewhart chart with the upper and lower control limits, 3 standard deviations above and below the mean. Here's a histogram. So for this example, they were showing ECG or EKG, which is American, turnaround time in days. So it's a cardiology physiology unit measuring how long it takes for them to do ECGs, and you can see that it's skewed down to the 1 to 2 days, but then there's a long tail out here, or even potentially a bimodal distribution, which might suggest that there is an inpatient population here and an outpatient population over here. This is the Pareto chart, which I probably didn't explain very well. But let's have another go. So there's a vital few here. So there's the 3 categories out of these 8 categories here, which contribute to the majority of the occurrences for error. So in this example here, errors during surgical setup, there are different categories such as wrong supplier, excess count, too few count, and then wrong size, wrong sterile equipment, missing item, damaged item, other. This sort of work has actually been done very recently in our own sterile services because of performance problems. And in this example, you'll see that the majority of the errors come from these 3. And you draw this line here, which is a cumulative percentage. So this one here is 60-something%. Then you add this here and you get the cumulative percent here. Then you add this percentage on and you get the cumulative percent. Then you draw a marker at 80% here, and then down to here, and then you'll see that these are the 80% of people that you want to concentrate on. And these are important, but if you focus efforts on these things, you're not actually going to make much of a dent in the error rate. This example here, staff satisfaction versus hours worked. Well, probably don't even need a scatter plot to understand this relationship, but it's just showing it in data for those who you're trying to persuade might not be persuadable, that the number of hours worked kind of drops off in terms of staff satisfaction. I would actually argue that maybe this scatter plot is made up, because probably staff satisfaction would be more like a curve like this, where if there's too few hours worked, staff satisfaction might also be low. But anyway. So now we're going to go on to a little video produced by the IHI, just to labor the point a bit more.
You'll need to turn the video up on your screen, please.
Sorry. Sorry, I think I might have pressed the wrong button. Let's try again.
Oh, I can't hear it. Sorry, James.
Okay, sorry. Oh, I wonder why.
I can kind of, but very, very, very quietly.
Right. Well, I can hear it very well, so I don't know what's going on. If I just, it might be.
You'll need to take your headphones off.
Yeah, that's what I think it's to do with. So, share computer sound. Right. Can you hear now? Can everybody hear that now?
Yes.
Yep. Okay. Sorry about that. We'll start again.
If we're going to try to do systems thinking, so appreciation of systems is a fundamental part of the science of improvement. And if I'm helping somebody, and so I need to appreciate the system, well, I have to be able to see that system. I remember when I would do work in auto organizations, they actually designed the big production plants there where you could go up to the very top of it and stand in the scaffolding and actually see the system working and how it's flowing and so forth to do that. In healthcare, it's sometimes very difficult to see the system. You know, hey, the system's a problem here. Well, where's the system? I can't see it. Where do we look at it? So what tools do we have that? So tools like flow charting, process mapping, and so forth that allows us to see the system is a pretty important tool. On the other hand, as I see people, if I tell people you need to have flow chart, they get bogged down in that tool. So doing flow charting, drawing systems maps is not improvement. It allows us to see the system to make that happen. So I'm always careful about ever overemphasizing any tool there to do that. Probably if there's one that I wouldn't do without on any improvement work or projects is a time series chart, a run chart, shoe heart control chart over time there. I always want to see that improvement's temporal. We have a past, we have the current, and we have the future. And I want a picture that helps everybody see that the same way. And so a run chart, shoe heart chart, I'll always have that on an improvement project.
Okay. Let me get to the next bit. Okay. So here's a little discussion, and feel free at this point to unmute yourself if you want to speak, or you can also just type stuff in the chat if you prefer. So when you're embarking on a healthcare improvement, why is it so important to see and appreciate the full complexity of a system? So Vanessa's saying different parts can easily be overlooked. Yeah, correct. I think it's really important to realize that not one person has a view of the overall system usually. In that example, you could stand on the top of the factory floor and watch the cars go round and round the plant. And that's possibly where you could get an overview of the system. But from a bird's eye view, you can't see the detail on the shop floor. You then need to walk around the shop floor and look at everything. But then you still might not know what it's like to actually operate one of the machines down there. So you either then have to then get experience operating every machine, which is not practical, or you simply just have to involve everybody and ask them. So yeah, mapping the process with process mapping, as it's called, which is a tool that you'll get to learn about on this course, is key. But he's absolutely right. You can get bogged down with this process. It can become something you want to get perfect before you move on. you might want to make sure you've talked to absolutely everybody, or you might want to make sure that every little piece is in position and every little variation is accounted for. That can actually take you away from the whole point of improvement, which is to get on with things and try things out and see if they work or if they fail. Other comments on the chat? To understand variation in order to accommodate them. Yep, absolutely correct. So if something is, if you got one of those run charts in front of you and there's some variation happening, if you don't know all the little components within your system creating that variation, you're not going to understand where you can improve things. You could miss something vital, absolutely. It helps keep things in perspective and appreciate all parts of the system, big or small. Yes, you need to make sure you don't forget about other parts of the system which are maybe not so big, but still important. And it's especially in healthcare, because in healthcare, we're trying to be completely inclusive. We don't want to disadvantage any particular type of patient or group of people who access or consume our services. We, unlike commercial industry where they can afford to actually ignore some sections of their population for profit reasons, we need to include every section of our population for equity reasons. So understanding our own system and every part in it is vital for that reason. You always need to engage the frontline worker in any healthcare improvement process. Absolutely. That's probably one statement where always is always true. Yeah, you do need to, because if you're not working on the front line, you don't know what it's like, you don't know all the little intricacies. It's the same too that if you are a frontline worker, you actually need to involve management as well in every healthcare improvement process, because you as a frontline worker may not have an overview or may not be aware of other things within next to your own system that have influence over your own system. So it needs to be a joining of frontline workers, clinicians, etc., nurses, allied health professionals, as well as managers, to be able to improve a system. Other comments. You often start a project because you have noticed a problem, but you want to know why there is a problem, or else you'll never fix it. Yes, absolutely. Also, you can assume you know what the problem is, and then it turns out to be something different. That's absolutely correct. And that's what data is really important for. It tells a story and it proves something. And one classic example is in the UK, where there has been this constant fascination for ED wait times since the 4-hour target was introduced there. And there have been countless investigations throughout each NHS trust to find out why ED wait times are going up and the target is being dropped. And the data always comes back saying it's because the flow through the system is not right. And that's not the flow through ED, that's the flow through the hospital and out the back door of the hospital. If you cannot get people leaving the hospital, you can't fill it up with more people, and therefore the front door, which is ED, starts to queue up. And it makes sense, and that's what the data shows, but it's not something that hospitals can easily change, so they don't focus on that. They focus on the low-hanging fruit, the things that they can change, and then wonder why they can't really make a dent in the ED waits. Your improvement may have adverse effects on other parts of the system. Important to be aware of these changes. Yes. So you would, if there's something that you identify from your process mapping that could be adversely affected, that would then become a balancing measure that you want to monitor to make sure that you're not adversely affecting something. The system is made up of all its parts. All parts are affected. Yes. So if you were thinking of the healthcare system as a machine with lots of cogs in it, each cog is vital for it to turn from one end to the other. And if you remove a cog, the whole thing stops. And that's if you use the machine analogy. And in a small system, like for example, a ward at the ward level, that's probably true. The problem is that that analogy breaks down when you start to think about at the whole DHB level or the national level. The system is then so complex that you can't really use that analogy properly, because things are not linear. Things are not completely dependent on one thing or before. The system has redundancy in it, so that if things break down within this in the healthcare system, other areas will compensate. So then you start to get something called a complex adaptive system in these larger systems. And it's something I mentioned right at the beginning of the first thing. So the difference between a complicated system and a complex adaptive system. So something as complicated as like very topical, which is happening in about an hour's time, sending a rocket out into space. There is multiple amounts of calculations and things like that that the scientists need to do, but if they got all the calculations right and they do the same thing each time, the rocket will get to the same place every time. But with a complex adaptive system, it's a bit like raising a child. So each child is different, and even if you have the same child, so you have twins, you raise them the same, they still turn out different. And that's because there's so many influences into the system that there's absolutely no way to control it enough to make it the same every time. And in that case, in a complex adaptive system, you're talking about trying to at least shape the environment around the system and hope it goes in a sort of direction to get to a sort of place that you want it to go, but you don't know exactly where it's going to turn out. So for your twins, you might want them both to be doctors, but it's probably not possible to get them to be exactly doctors unless you're pretty militant. But you can certainly try and make sure that they have a good education and end up in a good job. Okay, so the next question, there we go. How have you used visual tools such as run charts or flow charts to help with improvement? If you haven't used these tools, how do you think they could help you? So a little comment or chat message. So Vanessa says she uses control charts to track follow-up appointments per week. That's great. And presumably if the number of follow-up appointments per week drop below a certain control limit, then one might then investigate and find out that all the SMOs are off on holiday. And then all their holiday gets rescinded so that they come back and get that control chart looking better again. They can provide a focus for a meeting. Yes, they can. A very, very good way. And I've seen it being used extremely well in Unipart back in Oxford. This is a company where they were told they're the best example of lean outside Toyota. And they used run charts on the factory floor. And at the five minutes before a shift start, they would have something called a comms cell, where everybody in that area would congregate in a stand-up meeting around a board. And on that board was several bits of information, key bits of information that were discussed every morning. And there were a few charts up there to discuss packing times, packing stuff off for shipment. And they would look at the control chart and they would briefly say, we're working within the controls, or they would say, something happened yesterday, what was it? And if it was something that wasn't going to happen again, they would say, well, don't worry, that was just a freak thing. Or if somebody put their hand up and say, yeah, this is happening every so often, then that might actually turn into an improvement project. So what else have we said on the chat here? To measure key performance indicators, absolutely. To motivate people, yes. Used to check the number of patients seen in our department monthly against Ministry of Health timeframes. Yep, so there your goal line would be the Ministry of Health timeframe, and then you would monitor that accordingly. Yep, okay. In the video, Provost talks about getting bogged down by overusing improvement tools. Why do you think he warns against this? Used to check the number of patients seen in our department monthly against Ministry. Oh, I've read that one already. Sorry. Sometimes you start to lose sight of the bigger picture. That's right. Does the focus become the tool itself and not the work? Absolutely. Sometimes focus on a chart can distract from the focus on the reality on the ground. Yeah. Sometimes you just think in a linear fashion and you think, we can't move ahead on this project until this one thing is done. And this one thing that you've decided you wanted to do, like process mapping, becomes more complicated than you first imagined. It's important to then maybe step back and say, am I using the right approach to this? Is this the right tool? Or should we be looking at it from a different angle altogether? Good, okay, so we're gonna move on to the exercise now. Oh, hang on, don't go to that website, that's wrong. What I'm going to do is I'm going to send you a Excel spreadsheet on the chat. So if you open up the Excel spreadsheet that I've just sent on the chat, and we're all going to try this together. I'm going to share my screen to show you how to do it, and you can follow alongside me. So you probably want to open up the spreadsheet so you can see both the spreadsheet and the Zoom presentation. So that means you might need to go to the top and exit the full screen view if you're on full screen at the moment. So I'll give you a moment to do that while I also set up my spreadsheet. Okay, so I'm sharing my spreadsheet now. I hope everybody can see that. Please let me know if there's a problem. I'll give you know, a couple of minutes just to negotiate the technology, just so you have a similar view to mine on your own Excel spreadsheet. Okay, so hang on. just lost things for a second. Okay, so this spreadsheet here, you've just got a bunch of numbers. Now they happen to be, this happens to be the worst hospital in the world that you're working in currently. And you're the manager in the worst hospital in the world, and you've decided to count the number of complaints that come in every day. So you can have a quick eyeball at this run of the numbers, and you can see there's quite a lot of complaints here. And then the numbers maybe are a bit lower here. So maybe there's something going on, but you're not quite sure. And you want to represent this in a run chart so that you can then flash that up as a one picture story to then create your argument about change or what's going on, at least. So first of all, you need to turn this data into a table. So first of all, you want to create a header. So insert a row above this. Oh, hang on. So you just go insert. Why is my insert row not working? Okay, try this in a different way then. We'll cut it. Oh, I'm on a protected sheet. Okay, sorry. This sheet is protected. Let's copy the data. That's why it's not working.
James, if you go into File,
yeah,
you can unprotect the sheet quite quickly.
Yeah, no, I set it up protected because we were going to initially do it collaboratively on the same document, but I couldn't get the tech to work, so that's why it's still protected. But just to get around that for everybody, it's just we'll just create a new sheet here because it's just the sheet that's protected, and then paste your data into B2 like this. Okay. So now you have all the data running down a column, but you've got space above here to put a heading. So we're going to put complaints. Okay. Now the reason why there's a column here is because we want something for the x-axis. So here we're going to put date. And this happened to start on the 1st of January this year. So we'll do that. Now, you could continue to manually type all the dates, but there's an easier way to do that. So start off the series by doing 2nd of January, 2020. And then select the first two in your series. And then you drag the box down using this bottom right hand handle all the way down to the bottom of your list. And Excel automatically continues the series. Okay, the next thing you want to do, and if anybody is needing to slow me down, just either shout out or put something on the chat, okay? So then we need to turn this into a table. Now this is probably not so well used in Excel, but it's a really, really good way to organize your data. So whenever you've got a table with data in it like this, click this button up here, which is under the Insert tab on your ribbon. Click Table. And then it will ask you, where is your data? And it will automatically draw a box around where it thinks the data is. And also this checkbox here is usually checked, my table as headers. And in this case we have date and complaints as the headers of the table. So click OK. And now you have a table in Excel. And that table actually has a name if you see up here. So you can reference the whole table just with a name. And that's important when you're creating functions. So now we've got our basis of a run chart here in a table. So now we're going to turn this into run chart. On the Insert menu, you need to go to this icon here, which is Line Charts. And in Line Charts, you got many different options, but the one that looks like a run chart will be this option here, which is called Line with Markers. So you click that, and you instantly get something that's starting to resemble a run chart. You can see along the bottom all the dates from the 1st of January to the 31st, and up the top, up the left-hand side is our data, number of complaints. But there's one thing this run chart needs, and that's a median. In order to create a median, you can go back to your table and easily add that in. So to add another column to this table, it's as simple as just typing in the header. So I'm going to type in median, press return, and it adds a new column automatically. You can see that the color changes, showing that it's a new column of the table. And then you need to put in a function. And the function is, first of all, equals to bring up it as a function, median. Then press brackets, and then select the data. So you select from B2 down to the bottom, which is B32. Now take a little bit of time to notice what's actually written in this function. So because you're working in a table, it's no longer referencing the data as B2 to B32. The table allows you to use the table header as a word to reference all the data in that. And that's really, really important, because it means that if you add to your table later on, you add more lines of data below that, it will automatically include all the new data in that column. So once you do that, it automatically fills your formula all the way down every row in the table as well. And it draws a new line on your run chart, which looks like this. So it's starting to look a bit better. Now, oh, sorry. Now I'm going to make this a little bit more like the pictures that we were seeing on our course. First of all, we need some axis titles, and we need a chart title. So this little button up here helps you quickly add these things. And we also want a legend to tell us what these lines are. So then we're going to type in the chart title, number of complaints each day. And then on this axis here, we are going to put in count. And then on this axis here, we're going to put in date. Now the last thing that I don't like is that all these dots are on the median line, because that doesn't really look the same as our run charts. So an easy way to get rid of them is to right click on one of the dots, and notice that all the dots got selection bubbles around them. Click Format Data Series. Then you go to this Fill and Line option, and click on Marker, Marker Options, and click None. And now all those markers are gone. You still got the labels on the right-hand side. So now you can visually represent the fact that number of complaints each day seems to be following a downward trend after about this point. And you might have decided that actually there was something that we did around this point to bring the complaints down. And what we did here was that we actually shortened the hours in which the complaints office was open. So that meant that our patients no longer could actually lodge their complaints. And that's how we've managed to improve the system. So if you want to insert an annotation, you can do that by going to insert text, insert a text box. Just do this, complaints, department, reduced hours. And you can continue to fiddle, you can continue to fiddle around with this to get, the arrows in the right places, etc. But that's the basis of using Excel to do run charts. Now, I wanted to take the last 5 minutes just to show you some other tools which are available to use, which are probably a bit more sophisticated. So I'll show you on another sheet. Oh, let me copy this data again. We have a package that's available to us called QI macros. IT can help you install this into your Excel spreadsheet. If you click on QI macros, you get all the charts that they were talking about at your fingertips here. So the run chart was the one that we were talking about, and that is, where is it gone? Oops. Run charts, here we go, with a median. And you click a button and it appears, hey presto. So it's a bit quicker than doing it manually. But it's exactly the same thing. The other thing though that this thing has, it can do your control charts. So here, these control charts have a huge amount of things, and it's difficult to know which one you want to do, but most of the time it's these four at the top here. And we're talking about XMR median is usually what we would do for this type of data. And it will produce you a control chart. Now the R chart here is about variability, and tend to ignore that. But this here, it starts to label things as red as in special cause variation and blue as in common cause variation, and it gives you the upper and lower control limits automatically. You can also start to add breakpoints in it, so you can right click on that and add breakpoints, etc., to change the way your median is from here to here, for example. So it's really a very quick and a great tool to use if you're analyzing data, trying to mine the data and find out what's going on. Another tool that we use in that we're starting to use in the DHB is Power BI. So I will show that to you now. Where is Power BI going? So Power BI is quite sophisticated. You need to know how databases work, but I've been responsible for deploying a screening app down in the foyer, and now that's collecting a load of data. So yesterday I wanted to work out what's going on in terms of screening. I will show you the back end first. So this is where all the data comes into the system through a query editor. And all these tables come in, and I use queries to clean the data and model the data in order to prepare it for analysis. And this is especially true if you're going to use hospital systems such as the radiology system. There's a huge amount of cleaning that needs to happen in the data first. It's taking ages to load. So, oh, there we go. So you get tables. And one thing about Power BI compared to Excel is that you can start to analyze data with more than 10,000 rows in it. Because Excel has to load all the data into its memory. So 10,000, I think, is the maximum. Whereas in Power BI, it's more, it's up to the millions, I think. So that's the back end, and then you can produce a database looking type relationship diagram where you have these tables and they're related using usually indexes to relate the different tables together to eventually create graphs that look a little bit like this. And here in Dunedin, in the foyer, so you can start to put some filters on this and it live changes for you. In the foyer, we are getting screening increasing over the last 4 weeks, which is because we've been allowing more visitors to come. And over the whole period, the busiest hour in the foyer is the 2 o'clock. So people are arriving before 2 o'clock for their appointments, for visiting time, etc. And that's where a big surge is happening here. This is an interactive chart, so it can be, you can select certain data points and drill down. And it can really get more and more sophisticated. This is the desktop version that allows you to create the models. But for people just to view it, there is, hang on, back to meeting control. Just for viewing, there is share Google Chrome. There's a web browser which has a dashboard a bit like this, and it allows end users to have a look at the reports, but not having to create them at all. Currently, I think there's limited licenses for Power BI to use it because it's not officially yet the main tool for SDHB, but it's the way we're heading. Okay, so that brings us to the end of the session, and I'm very glad that you managed to come along. I hope that's been useful. If you've got any further questions, I'm happy to take them after the session. I'll stay online for another 5 minutes. You can either use the chat function or you can unmute and ask me. Thank you very much for coming. Bye-bye.